Okay, guys, we're going to look at section chapter 5.5. In this one, we're just going to kind of use the information that we've been given before synthetic division and try to determine what we can use it for and help us out. There's a lot of other things in here. Descartes rule showing how many negatives there are. There's a lot of different things you can do. This is the main thing that I want you guys to get out of it. So if you're looking for Descartes rule of signs, linear factorization theorem, by all means, go back online, check it out, reread it. But these are the few things that I really find that you need going forward and going into your next math courses. So we want to first evaluate this polynomial where x is 2. Now, our normal, before we've done this section, what we would typically do is we do 6 to the 4th minus 2 cubed minus 15 times 2 squared plus 2 times 2 minus 7. Perfectly fine to do. There's nothing wrong with it. Put in a calculator. You'll get the right answer. But tend to find students do this incorrectly, forget a parenthesis somewhere, forget an exponent somewhere. There's a lot of things that could go wrong with this. Perhaps put a negative instead of a minus sign. There's so many things that go wrong. So let me show you a way of doing this quickly. So we're going to do synthetic division. So when we say x is equal to 2, we're actually going to make our backwards L and do 2. Then we're going to do all of our coefficients. 6, negative 1, negative 15, 2, and negative 7. And we're going to do synthetic division. So drop down first. 6 times 2 is 12. Then we add them together, give me 11. 11 times 2 is 22. Add them together, give me 7. 7 times 2 is 14. 16. 16 times 2 is 32. Add those together, give me 25. And the nice thing about this is that means that when we put this into here, that means f of 2 is equal to 25. Super nice, easy way of doing it. This is especially useful SAT, ACT, any type of standardized mathematics to do it really, really quickly. But now what does this mean? So the whole point is that remainder is 25. But when we have a factor means that the y, in this case, is 0. So if we have a remainder of 0, that means that it's an x-intercept. So we're just using that idea. So this one right here, we're going to say x plus 2. So what does x equal? We say x plus 2 is equal to 0. So that means we're evaluating when x is equal to negative 2. Again, we put the backwards L, leading coefficients. Drop the first one. 1 times negative 2 is negative 2, negative 8. Positive 16. Make sure we don't forget negative 8 times negative 2. 15, and then negative 30. This means that x plus 2 is a factor. And not only that, we could rewrite this as x squared minus 8x plus 15. And we would say, what are my factors of 15 that when I add it together give me negative 8? Hopefully you can do that. That's x minus 3 and x minus 5. Ideally, that's how fast it should be as we're working on this. But now, we're not always given factors. We need to determine what they are. Well, the first thing we say is, okay, we want to know all the factors of 4 or constant. In this case, we have negative 4, which negative doesn't matter. We'll say 4. So our factors are 1, 2, and 4. But then we got to look at the very front and see where our leading coefficient is, and we have 2. So, and my factors of that is 1 and 2. So basically what we do is we're trying to find the combinations of 1 and 2. So that means we're going to divide each one of these by 1 and 2. So we've got 1 over 1, 2 over 1, and 4. Obviously that doesn't change anything. But then we say, okay, what is 1 over 2, 2 over 2, and 4 over 2? Well, in this case, 2 over 2 is 1, so it doesn't really matter. 4 over 2 is 2, so that doesn't really matter. So we only have 4 possible factors in this one. We just make sure we got to do that. Make sure it's very neat. So we want to find the zeros of this. So let's do it step by step. First is, how many factors do we have possible? Well, we have both a positive and negative 1. Oh, I forgot to state. All of these are both positive and negative. So not only do we have 4, but we have 4 positive and 4 negative. Positive, negative 1, and it can also be positive and negative 1 divided by 2. Now, for our sake, what I would typically do is, if you were finding 0, I would do 1 and negative 1 first. Always simplest number, no problem. For our sake, I want to do 1/2. And we're going to test this out. So drop the 2. 2 times 1/2 is just 1. So again, it's 2. 2 times 1/2 is 1. So it gives me negative 3. Oh, that does not work, because that would give us negative 3/2, and obviously that does not work. So let's try negative 1/2. See if that works. That's here. 2 gives me negative 1. 0. Let's make sure I did everything right. 2, yeah, so that doesn't work either. So I could try 1. So 2, 1, negative 4, 1. 2, 2, 3, 3, negative 1, negative 1. Oh, then that works. And this becomes 2x squared plus 3x minus 1. Still feel like I missed something up around here, but keep on going. Oh, let's see here. So we have a multiple. See, when we multiply this together, 2 times negative 1 gives me negative 2. So this is a final form. So what factor do I have as x minus 1? Now remember, this means this is equal to x. So we want to say, when does this equal 0? So we set the equation equals, that is how we get our factor. All right, so let's try this one. So again, what are our possible factors? Plus and minus 1 and 3. We also have plus or minus 1/3, and 3 over 3 is just 1, so we're not going to deal with that. So let's do 1/3. I'm purely doing this because I want to work on it, no other reason. Now I'm going to choose a negative 1/3. And the reason why I'm looking at that is, if I see I have all these positive numbers, I need something to be able to cancel out this 3. So I got to have a negative 1/3, negative 3 at the end. So I'm going to do negative 1/3 and see how it goes. All right, so it's 3 times, that gives me a negative 1. It gives me 8. Ooh, this is not going to be pretty. Negative, so that's basically negative 8 over 3. And then let's see here. That's going to be 5/3, and that doesn't work. Let's try negative 1. See how that works. Three, negative 3, 6, negative 6, 5, negative 5, negative 2. So it's still doesn't work. All right, so we'd have to go over again. My guess is either This is non-factorable. Oh, let's see here. Can we factor out another way? There is another way to factor this. We factor by grouping. 3x gives me x, 3x squared gives me x plus 3. We take out a plus 1, that's going to give me an x plus 3. So it's going to give me an x plus 3 and a 3x squared plus 1. So negative 3 would work on that. But now this right here, it would give me I would use a quadratic, and this would not be a feasible answer. And we would just solve this, would give me, if I set that equal to 0, 3x squared, if I subtract 1 from both sides, gives me negative 1. Divide by 3, which would give me x squared equals negative 1/3. And when I would take the square root of that, that would give me an imaginary number. The only possible answer in this case would be x plus 3, or when x is equal to negative 3. So that is my x-intercept. Sometimes it is just trial by error. And we didn't try 3. We tried 1, negative 1. We tried 1/3. We did not try 3 or negative 3. So again, but because we saw we could group them, it made it easier for us. Okay, so make sure that we understand how all this works. As I say, always try to do 1, negative 1 first. Then what I should have done is 3, negative 3, and then I should have done fractions. Fractions are the most difficult thing to do, and they do not always work. Okay, check out 5.6 to use all of these together.